Hey, question 21. So it's talking about here, some processors contain cache memory. Explain why cache memory can improve the performance. So again, cache memory, really fast accessing memory, very close to the processor, if not on the processor. And it really is good for holding frequently used instructions, just so that speeds up fetch execute cycle. So if you've got instructions that you're frequently using, it's a lot faster accessing them in cache than having to go back to the main memory. So remember, it's like a plumber or an electrician having a belt with all the frequently used tools on his or her tool belt, so they can get access to them really quickly. The ones that they don't frequently use, they have to maybe go back to the van or back to the toolbox. So you're really wanting to, because quite often that's about cache, but that's the main things here. Holds frequently used instructions, and it speeds up the fetch execute cycle. Okay, so that's for your 2 marks. Right, they're then saying that Yusuf has learned that processors perform a memory write operation. Describe the steps involved and make the use of the buses and control lines. So what we have with any memory reads or memory write, first thing is you have to have the address of the piece of memory that you're going to write to or read from. In this case, memory write, so we'll stick with that. So address is placed onto the address bus. So it's the address of the location of memory you're going to write to. You then want to get the databus ready, so the data is placed in the databus. So remember, keep on mentioning the buses. You can even highlight it just to keep yourself right. So at this stage we've got whereabouts in memory we're going to write to, and we've got the data all set to actually get put into that area in memory. So you just need to tell the control bus that we're going to write to it. Okay, so that just means it'll be going from the processor to memory. And once the control bus has that write line activated, then the data is transferred to the memory location from the data bus, or via the data bus is probably better. Okay, but that's the 4 stages. So set the address on the address bus, put the data in the data bus, tell the control bus, well, we're going to be writing, so we'll activate the write line, and then the data scoots from the CPU via the data bus to the memory location that you're pointing at up here. Okay, so that's your memory write. So this is something that your memory read and your fetch execute is something that you're wanting to know off by heart, because one of them will probably appear. Next one, okay, 3 marker, and they're saying that the maximum addressable memory is 64 gigabyte, and we've got the address bus is 32 lines, so we have to work out the data bus. Remember, if they start telling you the width of the control bus, they're just throwing that in, just to, it's a red herring, you don't need that involved in the working out, because what we have here, you'll have this memorised off by heart. Okay, so the maximal addressable memory is the width of the data bus, which we've defined out, times 2 to the power of the width of the address bus. So we have 64 gigabytes equal, this is the unknown, times 2 to the power of 32. So essentially, we're going to just be getting this value and dividing this into it. Okay. My wee tip is get this 64 gigabyte, convert that into bits first of all. Okay, so it's quite a long process. So times that by 1024 to get into megabytes. Times it again by 1024 to get to kilobytes. Times it by 1024 again to get into bytes. And then times it by 8 to get into bits. Okay, so 64 kilobytes, or sorry, 64 gigabytes is that number of bits. Okay, we've not touched this side of the equation yet, so that number of bits is still equal to the width of the data bus times 2 to the power of 32. Put that in your calculator and you'll get this number. And all you're doing now is you're going to get this number and divide it into that, and that'll give you the width of the data bus. And when you do that, you should have a number, it'll be an even number, and it'll be a number in which you'll quite often see it's maybe 64 or 32 or 24. In this case, it's a very wide one in which it's 128. Okay, so the width of that's 128 bits. Sometimes you see it as lines. In theory, well, in reality, actually, if you then put that into this equation, that would give you your 64. Okay, so you could double check it if you had time, but convert this into bits first. Work out this and then just divide it, and then that'll give you the width. Okay, so it takes a wee bit of time, but you just need to be careful making sure you're timesing it by the right thing. Okay, so that times it down there, and then you get it into bits. Right, so you then also have a question in which quite often this type of question does involve asking about maximum addressable memory cache and measuring processor performance. So they're really wanting to measure the performance of a tablet computer, and they use flops, and they're just basically asking, why is that the best one? Which it is, okay? And it is, it is industrial standard for measuring it, which is an acceptable answer, because it is, it's independent from the size instruction, because processors deal with these arithmetic operations the same way. Okay, so it's like when I ask a class what's 7 plus 7, you all work it out the same way. Okay, and the person that gets the answer quickest, I could say they've got the fastest brain, right? I know it's a simplistic way of thinking about it, but essentially it's independent from your clock speed and how complex instruction and instruction size, but it is an industrial standard, right? And you will have a note to say that, these arithmetic operations are carried out the same way in each processor, okay? So that's not, this is 4 examples of an answer, but there are other ones as well, right? And it says, explain why you would not use application-based testing to measure the processor performance, right? That's certainly application-based testing. They takes into account, okay, all these all these other different hardware issues as well. So explain why you would not use it, okay. Well, essentially that takes into account the databus with your cache, so it takes into account all the other hardware areas within the computer. Okay, so it's like test driving a car. If you're just wanting to test the aerodynamics, if you go about test driving it, well, what might affect the results is the engine size, the tyres, even the road surface. Okay, so do not take into account other aspects, cache, databus, width, etc. Okay, so that's why you wouldn't want to go down the route of application-based testing, because it does take into account all the other hardware affects the results. So that's that question answered, hopefully.